So today we will do few myth questions from calculus. Let's do with the first question. Question number 1. A set E is given to us as 1, 2, 3, 4 and set F is given to us as 1, 2. Alright, find the total number of onto functions. Total number of onto functions from E to F. Yes. Find the total number of onto functions from E to F. How to do? Total number of onto functions from E to F. Mr. Madhukar? Madhukar? Yes. Give me the idea. Yes, any idea for the number of onto functions? Now see, what are onto functions? Onto functions are like the range of the function should be equal to the codomain. Onto functions are what? Range of the function should be equal to the codomain of the function. That means in the set F, see this is E, that is 1, 2, 3, 4. This is F. F is what? 1, 2. So 1, 2, 3, 4. F is 1, 2. Codomain is 1, 2. You want range also as 1, 2. Means there should not be any blank element in set F. So required onto functions are like one has two ways to get image, 1 or 2. 2 again has two ways to get image, 1 and 2. 3 has two ways to get image, 1, 2. 4 has two ways to get image, 1, 2. So it is 2 to the power 4 minus. Now subtract two cases. Which two cases did I subtract? When all 1, 2, 3, 4 have image as 1, all. And when all 1, 2, 3, 4 have image as 2. I subtracted those cases when they are having same image 1 or same image 2. So your answer will be 16 minus 2, that is 14. Am I correct? Got it? Now, math question number 2. Find the range of the function fx equals to x square minus x plus 1 upon x square plus x plus 1. Yes. How do you do it? Find the range of the function fx equals to x square minus x plus 1 upon x square plus x plus 1. Try it quickly. Answer I tell you, its answer will be 1 by 3, 2, 3. See, to find the range of such kind of functions, what do? Let y equals to x square minus x plus 1 upon x square plus x plus 1. Got it? Now, if you differentiate this, let's not do differentiate, cross multiply. Yx square plus yx plus y is x square minus x plus 1. So y minus 1 x square plus y plus 1 into x plus y minus 1 equals to 0. Now this quadratic will have d more than equal to 0. So it is b square, that is y plus 1 ka whole square minus 4 times y minus 1 ka whole square more than equal to 0. Now I can write it like y plus 1 whole square minus 2y minus 2 whole square greater than equal to 0. Now it is a square minus b square. To factorize, I'll do a plus b into a minus b. A plus b will be 3y minus 1. A minus b will be minus y plus 3 greater than equal to 0. 3y minus 1 into y minus 3 less than equal to 0. So this implies your y belongs to what? 1 by 3 to 3. Got it? This is your answer. So this is how we find the range of this kind of rational algebraic functions, which are like linear upon linear, linear upon quadratic, quadratic upon quadratic, and so on forth. Got it? Now, see, the next question is limit x approaches to infinite. Limit x approaches to infinite, x square plus x plus 1 upon x plus 1 minus ax minus b equals to 4. Find A and B. Yes, tell me. Whatever the answer you got, just write your answer in the chat box. I give you 2 minutes to solve this. Just any idea? Values of A or B? quickly solve. Whenever you see any question, just jump over it. Take it on your ego that I have to solve it. Keep on doing something in that. Now see, this is limit x approaches to infinite. Take LCM as x plus 1. So you get x square plus x plus 1 minus of ax plus b into 2ax plus 1. 2x. x square का derivative 2x. Got it? Now it will be what? Limit x approaches to 0. See, coefficient of x square will be 2a plus 1 x square minus 2a. I just took LCM. Taking LCM, denominator goes x plus 1. Numerator goes x plus b into x plus 1. I made a mistake. Yes, it is x plus 1. Now if you multiply, so it will be a plus 1 into x square plus with x it is 1 minus a minus b plus 1 plus b. Got it? So a plus 1 x square plus x into 1 minus a minus b plus 1 minus b upon x plus 1. This is given as 4. Now you realize one thing. The limit x approaches to infinite is given to me. If denominator does not have a term of x square, then denominator should also not have the term of x square. Otherwise limit will be infinite or minus infinite. So from the numerator, it is minus 1 plus a. This minus a plus 1, it should be 0. So you get a as 1. Am I clear? Now, limit. Now your question left as limit x approaches to infinite 1 minus a minus b into x plus 1 minus b upon x plus 1. That is limit x approaches to infinite. Take x common from the numerator. 1 minus a minus b plus b by x upon x common, the 1 plus 1 by x. These two cancelled. Got it? Now, value of the limit will be what? 1 minus a minus b. So this 1 minus a minus b should be equal to 4. If you put a as 1, b will be minus 4. So your answer is a1 and b minus 4. See, have a look. Got it? Now, another question on limits itself. Limit x approaches to 0, sin x to the power 1 by x plus 1 by x to the power sin x dx. Yes, how to do? limit x approaches to 0, sin x to the power 1 by x plus 1 by x to the power sin x. Right? This is 0 की power 0 or 0 की power infinite form it is. Clear? Yes, guys, how to do? Just give me a moment. You give it a try. Yes, how to do? Anybody? Any answer, any idea? Give me chat in chat box. Oh, this dx is not here. Just the limit question it is. Limit x approaches to 0. Where is it? Sin x, see, we look this question very carefully. And we will solve these two limits separately. Limit x approaches to 0, sin x to the power 1 by x. First of all, if I see which form it is 0 raised to the power infinite. It is 0 raised to the power infinite. Isn't it? So as such, it is not an indeterminate form. It is not an indeterminate, but still we will do it. That is e to the power limit x approaches to 0, 1 by x ln sin x. What did I use? I used that a to the power x can be written as e to the power x ln a. A to the power x can be written as e to the power x ln a. So I wrote it like this. That is e to the power limit x approaches to 0, ln sin x upon x. Now see, if x is very close to 0, sin x is also close to 0. So log of this quantity will go minus infinite, and denominator is having 0, means it is also 1 by 0 means infinite. So this is what e to the power minus infinite it is going. So value of e to the power minus infinite goes 0. So this part is already sorted. Now come to the second part of the problem, that is limit x approaches to 0, 1 by x to the power sin x. Now see, it is very clear. It is, since x is 0, it is infinite to the power 0, which is a proper indeterminate form. Now it can be written as e to the power limit x approaches to 0, sin x into ln of 1 upon x. Correct? That is e to the power limit x approaches to 0. It is minus of ln x upon sin x to I took in the denominator. It goes cosec x. Now ln x is what? As x approaches to 0, minus infinite, cosec x is also infinite. So we will use L'Hospital here. Limit x approaches to 0. Derivative of ln x is 1 by x. Derivative of cosec x is minus of cosec x cot x. So it is e to the power limit x approaches to 0, sin x Sin square x upon cos x or niche one more x in the denominator. Now this sin x upon x will go 1 and another sin x will make it 0. So it is e to the power 0 whose answer is 1. So answer of this limit is also 1. Have a look. Very important and very good question. Yes. Got it? Now, next question is fx is given as mod x minus 1 mod. And now the question is draw fx and also find the number of points of non-differentiability draw fx and also find the number of points of non-differentiability for fx. Alright, give it a try. For the number of points of non-differentiability, you reply in the chat box. Yes, quick. See, first of all, how do we draw this graph? First of all, I'll draw the graph of mod x. Now, if you see this blue pencil is showing the graph of mod x. Now we want mod x minus 1. So to get mod x minus 1, what do I do? Just drag this entire graph by 1 unit downside. So drag the entire graph by 1 unit downside. Now again taking mod of this. So taking mod of this means what mod will do? Mod will copy the negative portion to the positive portion. So take the mirror image of this below the graph, below the x-axis to the above the x-axis. So it is like this. Got it? Now they are asking for finally the graph is like this. This then this, then this, and then this. Got it? This is the graph of mod x minus 1 mod. So how many sharp corners are there? 1, 2, and 3. So 3 sharp corners in the graph means 3 points of non-differentiability. Am I correct? All right. Now, let's do another question. Limit x approaches to 0, sine of pi cos square x upon x square is equals to what? Yes, please. Sine of pi cos square x upon x square, limit x approaches to 0. Yes, everybody please. See, it is limit x approaches to 0, sine of. This pi cos square x can also be written as pi minus pi sine square x upon x square. So that is limit x approaches to 0. Sine of pi minus theta is sine theta. So it will become sine of pi sine square x upon x square. Divide by pi sine square x multiplied by pi sine square x. So first of all, this sine 0 upon 0 value is 1. Then sine square x upon x square, again as x approaches to 0 value is 1. So the answer you are left with pi. This is your correct answer. Got it? Next question, very, very important. Limit x approaches to 1 under root of 1 minus cos of 2 times x minus 1 upon x minus 1. This is what? Yes. See, limit x approaches to 1. Now this is under root of 1 minus cos 2 theta. So you know a formula, 1 minus cos 2 theta is 2 sine square theta. Am I correct? So it will be 2 sine square x minus 1 upon x minus 1. That is limit x approaches to 1 under root 2 outside. It is mod of sine x upon x minus 1. So whenever a quantity comes out of under root, you have to put it in the modulus symbol. Got it? So now I have to do, since modulus is there, I have to go with LHL and RHL separately. So for LHL, I replace x as 1 minus h. So it is limit h approaches to 0, root 2 times mod of sine. If you replace 1 minus h, sine of minus h upon minus h. Got it? So it is limit h approaches to 0, root 2. Now this minus sign in the numerator will come out and will be absorbed by modulus. So numerator mein you are left with sin h upon minus h. Sin 0 by 0 kitna? 1. So answer is minus under root 2. Got it? Now you go with RHL. So you replace x as 1 plus h. So it is limit h approaches to 0, root 2 times mod. It will become sin h upon h. Am I correct? Now h is always positive. So it is limit h approaches to 0, root 2 sin h upon h. This is 1. The answer will become root 2. So LHL is minus root 2. RHL is root 2. So what do you say? Limit does not exist. Correct? Have a look. Done? Write down the next question. On the curve, y cube plus 3x square equals to 12y. On the curve y cube plus 3x square equals to 12y. Find the points where tangent is vertical. Do it. On the curve, find the points where tangent is vertical. Yes, quickly. So tangent is vertical means slope is getting infinite. Slope is getting infinite means dy by dx should be going infinite. So if you differentiate with respect to x, you get 3y square dy by dx plus 6x equals to 12 times dy by dx. So dy by dx is what? Minus 6x upon 3 times y square minus 4. Got it? So for dy by dx to approach infinite or minus infinite, so I should write it like plus minus infinite. Its slope should be going infinite. So this denominator of the base, this denominator of the slope should be 0. So y square should be 4. So y is plus minus. Got it? Now another question, write down. Find the minimum area of the triangle formed by tangents to the ellipse x square by a square plus y square by b square equals to 1 and coordinate axis. Give it a try very quickly. Very good question. Yes. Have you tried it? The question is find the minimum value area of the triangle formed by tangents to the ellipse and coordinate axis. See, let us assume we have this ellipse like this. Now tangent to the ellipse is this. This is the tangent. And the area they are talking about is this area. You have to minimize the area of this triangle. Am I clear? So now let us take a point on this triangle, that is A cos theta, comma B sin theta. Now in 11th class coordinate, we must have studied about the equation of tangent at this point. So equation of tangent is x cos theta upon A plus y sin theta upon B equals to 1. Am I correct? Now this tangent is intersecting x-axis at points A sec theta, comma 0, intersecting y-axis at point 0, comma B cosec theta. Correct? Because if you put x equals to 0, you get y as B cosec theta. And if you put y equal to 0, you get x as A sec theta. So with this, I got x intercepts and y intercepts. So area of the triangle is what? Half of base into height. Base is A sec theta. Height is B cosec theta. Am I correct? So it is AB upon 2. I can write it sine theta cos theta. So it will be AB upon sine 2 theta. Mod of this definitely area we are talking about. So it should be more. Now they're asking for minimum area. So area will be minimum if this denominator is going to be maximum. Correct? So area will be minimum. Area will be minimum. That will be AB if sine 2 theta is maximum, that is 1, means theta is pi by 4. So if theta goes pi by 4, area will be minimum and that minimum area will be AB. Am I correct? Have a look. Very good question. Also like required your knowledge of coordinate geometry, ellipse, tangent to an ellipse. Only then you could be able to do it. Am I clear? Very good. Now let's do another question. I is integration x square minus 1 upon x cube under root of 2x to the power 4 minus 2x square plus 1 dx. How to do? Yes, give me some idea. All right, that's a bit a tough question. Let's do one. This came in JEE 2016. X square minus 1 dx. Let us take x to the power 4 common from the denominator. So x cube is already there. If you take x to the power 4 common, x square will come out. Inside the root, it will be 2 minus 2 by x square plus 1 upon x to the power 4. Am I correct? So it will be integration. Now see, outside it is totally x to the power 5. So if I take it to the numerator, it will be 1 by x cube minus 1 upon x to the power 5 dx divided by under root of 2 minus 2 by x square plus 1 upon x to the power 4. Now let's do a substitution. Let 2 minus 2 by x plus 1 upon x to the power 4 as t square. 2 by x square. Now if you differentiate it, you will get 4 upon x cube minus 4 upon x to the power 5 dx as 2t dt. So here also multiply by 4, divide by 4. So you get 1 by 4. Now the entire numerator is 2t dt upon t. This tt cancel. So it is 1 by 2 t plus constant. So 1 by 2 under root of 2 minus 2 by t square, 2 by x square plus 1 upon x to the power 4 plus constant. Very good question. Got it? Am I correct? Anyways, that would be all from my side today. And now I would like you to give just small feedback about today's session. Yeah, there you go. Please.